Compose Multiplatform is a library by JetBrains. It has alpha support for iOS, and it has web support, experimental, and has Android support, desktop support. There are two approaches you could take to use KMM. Hi, first thank you for coming on a Friday, 9 o'clock. I give you something for free, but I don't have anything. My name is Mohit Sarveiya. I am a Google developer expert in Kotlin and Android. I have my Twitter handle there for some reason. So I am from New York. This is how many people have been to New York? Oh, great, thank you. And if you haven't gone, I'll give you all a free trip. Just kidding. This is my first time in Italy, and it's been great. Turin is a great city. All my friends did not know about it. They asked me, why are you going to Turin? I said, because I'm giving a conference talk. I never given a keynote. I'm nervous. Emily yesterday gave a great keynote, and I have to follow it up. It's going to be hard. And she had pictures of giraffes and animals. I like animals, but I don't have any pictures because I can't draw. I have code in my slides. So I want to ask a question. How many people here have built a Kotlin multi-platform app? It doesn't have to be in production. All right, great. So that's about 1% of the room. That's good. It means my talk will be informative, hopefully. So what I'm going to talk about, before I start, how many people had coffee before this? That's great. So if you fall asleep, it's not my fault. So my talk is about how do you set up and build a KMM app, Kotlin multi-platform app, and how do you use Compose with it. I will go into the internals because it makes people sound smart. And I'll talk about interoperability with iOS. How many people have built an iOS app? Wow, that's great. My talk will not be confusing. And so I'll talk about how do you use, suppose you have an iOS app with SwiftUI and you want to use a piece of your UI in Compose. How do you use it in SwiftUI? How do you go the other way around? How does the interoperability, the bridging work? That's what I'm going to talk about. So, Compose, so KMM is supported in different platforms. You got Android, web, iOS, desktop. How many people have an iPhone, use an iPhone? That's great, because I'm thinking of getting an iPhone. And how many people use Android? Great. I'm asking dumb questions. So so with KMM, you could share, KMM has, up to this point, has been used a lot to share API code using a library called Ktor, built by JetBrains. And you could also share not just your repositories, but also your data layer using libraries such as SQLite. And you could also share your business logic, your calculations, common calculations you would have. And now you could share Compose code. You could share UI components. And why would you want to do that? You would want to do that because if you had a complex UI, so you don't have to convert everything, and I'll talk about that. So Compose Multiplatform is a library by JetBrains, and it has alpha support for iOS, and it has web support, experimental, and has Android support, desktop support. There are two approaches you could take to use KMM. And one approach is that if you're working on a greenfield project where you're working on an app, you're building it from the ground up, you may build your whole app in Compose, in one code for iOS and Android. That's good for greenfield projects, but what if you're working on an app that already exists? in iOS and Android. And you have a design system built out for your Android app. You got a design system built out for your iOS app. What you could do, another approach you could take, is that you could convert just a piece of the UI which is important in Compose, and use it in SwiftUI. And I'll show you how to do that. So this is a good approach to take. So what's a use case? What are some use cases that are good for sharing on iOS and Android? Like you could, like for example, like if you build in Compose something that has a lot of gestures, you know, something that's as complex as that, or something dealing with Canvas, for example, because that helps you to use one coordinate system on like iOS and Android. So those are some examples you could use this approach for. Those are the two approaches, and it all depends on your needs. So I recommend sharing individual components that are complex, that you find will provide a lot of business value. You won't need like a lot of developers because you're writing it in Compose and Kotlin. And so for this app, for this conference, for this talk, I built an app to show an example of how to go about using Compose in SwiftUI. I built an app, and look at this app. It looks nice. This is an iOS simulator screenshot. I have pictures of my favorite place, Amsterdam. I'm sorry. I also like Italy. This is an app I built to learn SwiftUI. It's a beautiful thing, and it displays a list of images, and when you click on them, it displays you tags and location. And what I'm going to do, our goal for this, is to convert this list of images to Compose. But we're going to keep everything else. Everything else, the toolbar, the navigation, and I just realized these pictures look pixelated. It's not my fault. And we want to keep all of the other things, the toolbar and everything in SwiftUI. We want to inject a Compose thing in there. Now, when you look at this, you might think this is too simple. Obviously, it is too simple. Otherwise, this presentation would be complicated. So I went for simplicity. Good to go with something simple first to learn. So this right here is SwiftUI code. Don't get excited or scared. Who's scared? Oh my. Oh, I mean, two people raised their hand. I'm sorry. This is SwiftUI code. And a Z-stack layers things on top of each other. And it's simple. It's easy peasy lemon squeezy. This is a lazy vertical grid, the same thing in Compose. And I'm going in there and I'm basically displaying the images in a for each. The beautiful thing here is that there's a task API in SwiftUI. So that's similar to like launching coroutines. The task API tears down when this UI goes out of the screen. And I'm there telling my repository, get me images using async await in Swift. And I left out the code where I'm updating state, but that's irrelevant. What I want to do is take this piece of code and convert it to Compose. And I want to be able to use that piece of code here. It's something simple, but bear with me. Bear with me. Okay. It was great spitting out that SwiftUI knowledge I learned. I hope it's all correct. So this is all wrapped in a beautiful navigation view. You know, navigation on iOS is nice, and what I want to do is that I'm going to create a method called Compose View, which is going to basically port over and call my Compose code. Now it raises questions, and I'm a thinker. How many of you are thinkers? Yeah. So one question is, well, in this world, it's all about UI view controllers, right? And how do you bridge that to that world? And how does it all work? How does it draw to the iOS screen? How does that work? It's good to be curious. And so to build Kotlin multi-platform apps, right? Using Compose, they have a template. And JetBrains made a template, beautiful template. You click that use template button, you make a repo out of it, and this thing works when it has a simple hello world program. This is a good starter to be able to build off of this template. I see people are taking pictures, that means this slide was useful. So what is the structure that it creates when you use this template? Well, it creates three things, three modules: an Android app, iOS app, and a shared module. I'm going to ask you guys a question so that you're still awake. You could shout it out. No need for a mic. So if you impose in KMM, the shared module, when it builds, what is the artifact that the Android app consumes? What is it called? Whatever you said. It starts with you said something which starts with an A, and that was not correct. But good. Oh, it's a jar file. It's simple, jar file. Okay, here's the interesting part. What about an iOS app? You have a shared module, shared library, shared code. What is the artifact called that gets created, consumed in the iOS app? Anyone? Oh, there's the Objective-C framework. Thank you. I will give you something. Free coffee. So thank you. Yeah, that's right. It's an Objective-C framework. It's not a SwiftUI framework, and that has its challenges. There was a great presentation yesterday on how do you build APIs to make it Swift friendly. So it's an Objective-C framework. So in the shared module, you got common main, Android main, iOS main. Why is this important? Well, in common main is where you write your common APIs, hence the term. But you have access to platform dependencies in Android main. In iOS main, you got access to UI kit because there are bindings for it. You got access to core UI in iOS. So you could set up your UI, and I'll show you that, in which you have a common interface defined in common, and then you implement how that gets implemented in Android and iOS using platform-specific dependencies. That's powerful. So let's look at what you put in your build script. I made that icon. I drew that beautiful thing. So, thank you. I just enjoy you guys are playing along with what I'm saying. So when you use Android Studio, you could use IntelliJ, or you could use Android Studio, you could use Xcode. Some people use a combination of all those things. In Android Studio, IntelliJ, there is a Kotlin multi-platform plugin. It's a beautiful thing. Why? Because you could launch iOS Simulator in the Android Studio, and that's nice. And so in your build script, you specify a Kotlin multi-platform, and then you specify some common dependencies. So material compose dependency has KMM support. You have foundations, you have these other things, and you put them in there. So this goes in your common build script. So let me show you now how to go about after we have our project like this, how do we go about accomplishing this goal? What happens underneath the hood? And this is where things get interesting. What happens, how is Compose View implemented? So this is how it's implemented. Look at that. It looks like a subway map in New York, or the train I took in Metro. In Compose View, there are utilities that Kotlin multi-platform library provides that create a UI view controller for you. They bridge things together. They take your composable method you want to use on iOS, and they know how to go about setting up the window. They know about how to draw things, and we're going to look at how that works. So what I'm going to do, what is images list? Images list is my composable method, which displays a list of images. And the first thing I'll do is to create a theme. Just like you do in an Android app in Compose, you could use themes. You could use the material theme in KMM. So I'm going to define a light and dark palette. I'm going to define a composable method called images app theme. And then I'm going to specify basically whether to use a dark theme or the light theme. So this is some standard things that you would do, right? Nothing special. How do you go about using this theme now? Let's go deep down into Compose View, how that works. So this is SwiftUI code, and this inherits a protocol, UI controller representable. What a name, what a name. This thing here has a method in which we are going to call our images list method, is going to create a UI view controller. I'm going to use something that KMM library provides, which is the bridge, basically. And what that is, it looks like this. So this right here, Compose UI View Controller, is the bridge that the KMM library provides. And the Lambda block here is where I specify the Compose code that I want to use in iOS, basically. So the way that the way this library works, there is, by JetBrains, there is, Compose Multiplatform is a library, depends on a core library, which is a fork off of the Android X library. And they modify it, they added support for iOS in there. And this is a screenshot, look at this. In this screenshot, you can see that there are commits to it that get added that are like that fork off of the Android X one. And I recommend reading the source code. It's great to read source code. So how does this look? The way this looks, and this is where things get interesting. When you look underneath the hood of how this works, how does it take the compose thing, whether it's a column, row, text you want to display, and how does it draw it on the iOS app? So on iOS. So what it sets up underneath the hood is a compose window management, just like you do on Android. And it takes in your content, which is the composable method, composable content you want to show. And then what you will do is to specify basically, so in here I have a simple hello world that I want to show, right? I'm not showing a lazy list right now. I just want to show a hello world, and how does that display? Let's look at it. So this is how it displays, the hello world in an iOS simulator. So when you look at in Xcode the view hierarchy, it looks like something like this. And it's not what you may not expect. And when you look at this, you see that there are a couple of things that it made. You have the Windows scene, the UI window, which is iOS things, but it made a compose window layer right there, and it made something called Seco UI view. You'll always see that. That Seco UI view is the layer that draws, basically maps between what you want to show in Compose to the actual drawing. So what does Seco mean? Seco is a library which is a Kotlin multi-platform binding library for something called Skia. Skia is a multi-platform library for drawing lines, circles, etc. And how many of you have used Skia? All right, great. So we have hands, which is always good. So basically, this library is able to, so this is a Kotlin multi-platform bindings for it that it's using. So it maps basically like all of those to drawing commands. Like when a recomposition happens, it's going to map to drawing commands. And that's what that Skia layer at the bottom is doing. And let's look at the source for that. So this is something I stole from the KotlinCon talk, because that's what I do. Great artists steal, they copy. So I basically, this is a structure, architectural structure. When you take a step back and look at the source code, you'll see at the bottom is where the Skia layer is, and Compose, that's where the layer is of the window management layer. So basically, the window, Compose window, sets up the window, and what it does is that it takes this piece of code, which is the content, and then it goes in here, it creates the layer. As you can see there, this is a UI view controller. It has to be because iOS understands only this, this world UI view controller, and it's setting up that Seco view, you can see right there, and it's adding it as a subview, which is what you saw in the view hierarchy. So load command is important. It's loading all the Skia stuff that it needs right there. And then right there, you can see that it provides it the content that which is your composable method, and it sets up composition locale providers. So this right here is where all the magic happens. And it's great. So basically, this is how that piece of code works from the bottom up, right? It's good to understand that. So now the question is, how do we display our list of images? And that in itself introduces a couple of problems. One is, how do you load images in KMM? Coil is not supported right now, does not have KMM support, but they got support from JetBrains to be able to migrate that to KMM. But there are other libraries that allow you to display images. We're going to look at them. There are other questions that pop up. when you're building this, do you want to share view models, not just your repo? And there are different approaches you can take. There isn't a one-size-fits-all. Let's look at that. So let's look at architecture. So how you're going to architect this to display this list of images. And I might do something controversial, but I like controversy, it makes people talk. And what I'm going to show you is you don't have to do this. This is not a one-size-fits-all, where I'm going to share not just the repo, but also the view model and the view for that particular piece of UI. You don't have to take that approach. You know, people have opinions. You don't have to share your view model. I see that guy laughing, so that means something. So you could just share your view model if you want. So let's start with the architecture. You know, how many people use MVVM? That's great. MVI? Very few. Very good, I guess. I like MVI. So I'm going to use an MVVM architecture. You have a view model that interacts with the repository. These are beautiful animations. You know, I don't use animations a lot, but I did it for this with a response. And then you have a UI state. The view model pushes, and the view model is listening to an event. You know, MVVM. So what I'm going to do, this is the exciting part of my talk that I'm looking forward to showing, which is I'm going to use in my view model library called molecules to set up the state stream, to set up this state stream right here. Oh man, I've got to go through the animations again, which is where the view model pushes out a UI state. You know, the view model pushes out a UI state with how many people use coroutines? Very good. That's good, Martin. That's, yeah. I'm sure you guys use state flows. You know, you could set up a state flow, you push that, the view model pushes it to, and the view listens to that, right? How do you do that? So, well, one way you could do that is to use molecule. Molecule, I guess why would you want to do that? Well, first, I mean, there are many, many reasons. That's like another talk I gave last year at Droidcon NYC. And where you could, gives you a good mental model of it, and of things, when things get complex. So Molecule is a library that's also multi-platform, which is why I'm presenting it here. And it's a library that allows you to set up state stream. Now yesterday, we had a great, what is that called? Where a lot of people sit here. There, that's it. Okay, I got nervous, I forgot what that's called. So where we talked about Compose. But the word compose, a lot of people think is just about UIs. And that's a problem. The naming is a problem because compose is not just compose. There's a difference between compose and compose UI. Compose UI is about rows, columns, how do you want to display. At the bottom of that layer, compose UI is an example of using the bottom layer of compose. Compose is basically a library, a compiler plugin, Kotlin compiler plugin that knows how to manage a tree of nodes. Whatever the node is could be, in the case of Compose UI, a row, a column, etc. But you could use it for other things. There's a library called Mosaic, I think it's called Mosaic. You could use it to build terminal apps. You could also use it in this case for a molecule. So Compose, that's a good distinction. You know, when you say compose, what do you mean? Compose UI, what are you talking about? So how do you use molecule? So this is an approach that I'll show you. In Molecule, when you're creating a composable method that has your logic on how you're going to update state from one to the other, loading, success, failure. How are you going to go from one to the other? You can have many different states depending on the complexity of your UI. And what that does, basically, what I'm going to do, what Molecule does is that it takes that and it sets it up in the Compose runtime. There's something called snapshot state listener that you could set up. There is an API that allows you to hook into the Kotlin compiler. I recommend all of you to look at that. Great talks been given by people who work at Google, by, what's his name? Oh my God, I forgot his name. He's a great guy, so hopefully I'll remember. I met him a month ago, damn. So what it does is that you basically create a state, it creates a state flow. But it uses the compose runtime to listen to recompositions from that composable method. And when that happens, it basically pushes to the state flow for you, to that stream for you. And that's how that library works. And so when the recomposition happens, it pushes to that state flow. Look at this animation. What a beautiful thing. Look at that. Look at that. Thank you. I hope that was not a sarcastic laugh, but I don't know why this screen is blank, but I hope you have a clock. So there's a concept of a monatomic frame clock, which has to do with your refresh rate. So when a tick happens in that clock is when it basically knows when to push to the state flow. And I bring this up because this library uses specifies a state frame clock for iOS, but also for Android, depending on which platform you are in. So basically a frame in this film gets, with a tick, it basically gets emitted when a recomposition happens, and then when that happens, it pushes to the state flow. That's how it works underneath the hood. A little bit of preview, but check out my talk from Droidcon NYC last year on more into how this works. So let's look at how to utilize this. So Kotlin Molecule has multi-platform support for iOS, Mac OS, JS, and Android. And so another thing, and when we use our view models to share them, one problem is that we need them to be lifecycle aware. And there's a library you'll see in the JetBrains samples, and they use a library called Moco. What a name, named after my name, which just has 2 letters, M-O, like M-O-H-I-T. So Moco is a library which provides you with lifecycle care aware components. You don't have to use this library, I'm just a messenger. Basically, this library was good to check out the source code, how it builds an API to basically provide lifecycle aware components for Android and iOS. How does that work? So basically, the thing that I'm going to do first is that I'm going to set up a state machine. I have my UI state seal class. All of you know what this is, right? Loading, success, error, right? It's simple. I'm going to create a view model. It's abstract class view model. Some people might think I'm over-architecting, but that's okay. I'm going to set up some scaffolding. What a word, scaffolding, to be able to use this for all my view models. I'm going to set up a pattern, a mental paradigm, you could say. So I have a molecule view model, which the model is 2 generics, what UI state that is going to emit, and what events I'm going to take in. And it inherits the view model class from Moco, which is lifecycle aware. So I'm setting up a view model, and this is KMM. I'm going to also use molecule for that. First thing I need to create a scope. So in Android view model, it creates a scope. Does anybody know what the context and dispatcher uses on Android? Man, so similar to that, I'm setting up a scope here. And view model scope is what Moco sets up that I could use. So when I create a scope like this, a coroutine like this, it sets up a parent-child relationship between things. And because I'm passing in a context. And so I get structured concurrency. And the other thing is that, the other thing that I need to specify here when I set up the scope is what frame clock am I going to use. So this is KMM, right? It has to be something that iOS and Android understands. On Android, you got Android UI frame clock. I recommend the Compose book. I want to ask if you have read it. Compose Internals. How many people have read that book? 1, 2, 3, that's not good. You need to read that book. Great book. I recommend a guy who went and wrote a book. He read the source code. And he's a fellow GDE. I recommend that book, Compose Internals, which go into the source code and really explain to you how Compose works in a very understandable way. Really recommend that. And this library molecule sets up another clock called display link clock that iOS understands, which is this screenshot from their documentation. So we're going to utilize this. So does anybody know what the plus does? What does the plus do? That's it. he made a gesture, he did this. That means that it adds it together. That's it. So whenever you're setting up a coroutine, you set up the context. You want to add context elements. You want to name your coroutine. That's another context element. You use the plus sign and you could add them together. Important thing to understand. I love coroutines. Oh shit. I do love coroutines. And sorry for cursing. New Yorkers curse. So this is the display link clock that Molecule utilizes that we're going to use, right? And basically the way it works is that Molecule provides an extension on the scope called launch molecule. Why is it called molecules, like chemistry, right? Because there's a nerdy analogy which I won't get into. But basically in there, I have a models method. This is where my business logic is, the composable method that I make that knows how to go from one UI state to another. And basically what I'm doing is that when I call launch molecule, it gives me back a state flow. And whenever a recomposition, the models method happens, it pushes to that state flow so my UI could read it. So that's how it works. So basically, the other thing is now, how do you listen to state events? You click on something. You want to make UI state changes. How do you listen to that in the composable function? How do you do that? And let me show you how you do that. I am going to create, not a state flow, a shared flow. And shared flow has differences from a state flow. And this has an extra buffer capacity. There's a way to handle that when you fill all that up. How to handle overflows. And I'm going to create a method that I'm going to call from my view that basically listens to where you push state events to my composable function. And there's a way to listen to this in my composable function using Molecule. And let's look at that. So let's create the view model. I have my images view model that inherits all that scaffolding from my Molecule view model. Whenever someone is creating a view model in your KMM project, the only thing they're going to have to do is inherit from that. And you'll see this in the sample in Molecule. That Molecule view model was created by my colleague. Shout out to Chris Horner, great guy from Australia. And you override the models method right there, and you take in a flow of events, which are UI events, and you basically put in their logic that you want. So I have here something called remember, which is what Compose understand, which is how you set up state. So loading is my default state. And basically what I'm going to do here is I'm going to do a launch effect. And basically there is where I could make network calls. Wait, how many people use Compose? You know what launch effect is? Oh, you know launch effect? Look at, thank you. Okay. Not a lot of people in the back, but we're going to work on that. And launch, there's so many other great talks I recommend going to on Compose. Launch effect is how you do side effects, like making network calls, and I'm telling my repo to get me images. When I get them back, I'm going to update my UI state. I don't handle errors. That's what you should do. You should handle errors, right? This should be a result type where you could update the state, right? So that's a good thing to do. Just for simplicity, I didn't do that. Then you return my UI state. So you could also now in this here, collect basically from that events flow and then change the UI state depending on which event happens. So this is where all you would put your logic in here. And this is something simple, but this can get complex if it starts to get big, basically. That's a story for another talk. So in my app theme, the way I create a view model, get an instance of it, is that there's a Mako provides get view model, and I'm creating provides me with a view model factory where I'm going to create an images view model. And over here is where I talk about DI. Controversial topic can be. It shouldn't be controversial, it's a simple concept. But in Dagger, how many people use Dagger? Great. Dagger is not KMM support. You could use Coin, which is more of a service locator pattern. How many people use Coin? Well, very nice. You could use Coin or you could do manual DI. Whichever you want, whichever floats your boat. So basically there, I'm now going to get an instance of my flows, and collect as state is an extension on a flow that converts. If I didn't, okay, I have a question. If I didn't do by and it was equal, what would be the type of model? Very good, very good. You guys are so smart. And that is right. So by is a delegation. I recommend you use that. Pulls out the type from that state holder. And the type of model is UI state, my seal class that I had made. And I'm going to pass it to images list, which is my composable method. Finally, we get to the view, which is shared, which is very simple. Nothing, nothing exciting there, just a lazy vertical grid. And basically, another thing, which I, just for simplicity that I don't show, there are good practices to follow when making composable methods. You want to have a default modifier at the beginning, always. I don't have it here. And that's okay. But basically, and all use stable types, everything I was saying in the round table. So where you display or lazy vertical grid. So how do you display an image? Over here, you got an image right there, a path to it. How do you display it? So there's a library that's using JetBrains samples. There's many different libraries. One of them is called Camel with a K. What a name, Camel. And it has a lot of information, simple to use, similar to Coil, which is you use Camel image, you specify an async painter resource, and you give it a path. And it's that simple. So this, then, when you have this code running, it will display a list of images. That's how you set that up. So here, I shared 3 things. You don't have to share the view model or do what I did. It's up to you. You could share the view and the repo. That's it. You could also take that approach. The last thing I want to talk about is iOS interoperability, which is basically what I showed you is how do you use a composable method inside of a SwiftUI, but then how do you go backwards? How do you use in a composable method a SwiftUI code? Why would you want to do that? I don't know, but it's cool. Let me show you. Here I have a view in Compose, and I want to use a SwiftUI view. So there's a way, there's a utility that they provide, in which there's like a factory in which you provide a SwiftUI view. Let me show you that. So you set up, suppose I want to set up an example of a common main and app screen. I'm going to set up a composable method. I forgot to add composable, but whatever. So you set up a view controller. You set up a column like I showed you. And underneath this text, I want to show a SwiftUI view. So there's a factory utility that they provide, UIKit view, which takes in basically my Lambda block, which returns a UI view. That's where my logic for my SwiftUI view is going to be. And how does that look? How does that look? Well, this is how it looks. This is Swift code. This is a UI controller representable. And right here, I'm calling my app screen method vstack. This is SwiftUI code right there. So that's how you go the other way. Why would you want to do that? I don't know, but this is cool. So lastly, talk about one last thing. When you're building this, you may have an instance where you're displaying a date picker, but I want it to be a look and feel of the platform, like on iOS or Android. And this is a good example I'm going to show you of using expect and actual declarations to build an API. Trust me, this is the last thing. There's something called a TV app. How many of you know the TV app by Chris Baines? Wow, very good. Chris is a great guy. So Chris, this is a repo that a lot of people go to see examples because he does so many awesome and cool things. And in here, he uses KMM in here, so check that out. So this modal that you have here, this is in Compose. This is in a in an iOS app. This is in Compose. When you click on date, I want to show a date picker that looks native. I want to show a date picker that looks native. On the Android side, I want to use Material 3. On the iOS side, I want to use UIKit. How do I do that? How do I do that? The way you do that is that in common main, I could set up an API that looks like this. expect fun, expect actual declarations. And this is a composable. It's the bare bones of how you build APIs with Compose. And Martin is giving a talk later to talk more about that, best practices for that. I recommend you go to that. And here I want to create a time picker dialog for this. So in my iOS main, I'm going to you're going to use the keyword actual. So whenever you set up expect, it expects you to set up, it'll give you an error. If you don't specify actual declarations for each platform, desktop, JS, blah, blah, blah. So date picker view controller is something I made. I have access to the UI bindings for my core UI in iOS, and I'm basically adding them to a subview to create a native feel to it. So on Android, the way you'd set that up is just by using something simple, date picker dialog from Material 3. So what I'm doing is that I have a fork, basically, and with this API, the method gets called depending knows within which platform to use, what logic to use. So that right there is something simple, that is very useful. You should check that out. That's interoperability, right? That's interoperability. And Kotlin Multiplatform Compose 1.510 preview is out. I think there are other versions. Oh, people taking pictures, very good. There are a lot of additions that were added here in the changelog, and I recommend that. New Material 3 components, and then you have a show more link. So basically, what's on the roadmap? On the roadmap, we have navigation support. I didn't go into navigation, but there are libraries like Voyager that you could use in the community. Decompose, not a great library. I don't know why I set that in an exciting way, but navigation, using navigation library is controversial because it's frameworky. But you could set up navigation yourself also if you want. So there's navigation support, transition, text selection, accessibility, dialogues, and pop-up. All those things are on the roadmap. And so that was my presentation, building multi-platform apps with Compose. And I hope that found that useful. You learned about internals. And I said a lot of things. And lastly, I want to say that first I want to thank Droidcon Italy, first time speaking here ever. And I'm enjoying it. And I want to say that, what do I want to say? I want to say that about 3 years ago, I was in a point where I had first, I never thought I'd present here because I deal with imposter syndrome just like everyone here. I never thought I'd be good enough to ever even give a keynote or a workshop or be on a panel. And it's been a long road to fight imposter syndrome to think you're good enough to present here. So I want to say thank you so much for coming in the morning to my talk. That's it.